Notice, and this is the typical copyright. We continue with mathematics syllabus for CSEC 2018 to 2027. Schedule of videos. These first three sections here, all 51 of those videos have been published in their entirety on YouTube. Section 4, measurement. All 17 of these videos are completed, but only 5 are published in their entirety on YouTube. We are now on section 5, statistics. This is the 14th of 18 videos. And then section 6, algebra. Section 7, relations, functions, and graphs. Section 8, geometry and trigonometry. Section 9, vectors and matrices. I am well behind schedule, so I have to readjust that schedule later. Note that in this video, video 14 from this section, I will skip most of the usual introductions. We are now here, objective 10, part B, video 14. So there are 18 videos in this section. We got up to here, 13 in the last video. These have been published in their entirety on YouTube, and these others only partially published. So as I said, we are here, 5.10 part B. Video 14, we will be looking at 4 more graphs. And once I finish with this, it will only be partially published. Section 5.10b, analyze statistical diagrams. And to do that, we would have to find mean, mode, median, range, quartiles, interquartile range, semi-interquartile range, and if there are any trends or patterns. In this video, we will consider 4 more graphs, 2-line graph, one from ungrouped data and the other from group data. We will also look at a histogram and a frequency polygon. And that will be all the time we will have to spend on this objective. 2 videos. So we continue with analyze statistical diagrams. We now move to line graph, where it is ungrouped and somewhat processed, so it's not totally raw ungrouped. Now, of the 4 types of graphs you were told to be able to do, to construct pie charts, bar charts, or column graphs, line graphs, and histogram, the line graph seems to be the most versatile. Keep that in mind when you do your SBA for other subjects. Think of interpolation and extrapolation, gradient, line of best fit. This was when we were given the information in this table here, and we were asked to find measures of dispersion from the table. Now, that table was used to draw a line graph, and we have to find certain information from the graph. So if that table were used to draw a line graph, this is what it will look like. However, that's not likely what you will be given, because you may not have these data labels here. More likely, you'll be given this. Remember, you're not given that table for this objective. You're given this graph, and we have to extract those pieces of information from it. So let's begin with mode. It is a 1 or 2 with the highest frequency. And in this case, that is 56 kilograms. If we double check it against the table, we could see 25 times 56 appears. So that's the mode. We are just using that table to double check our answer from the graph. Next, we look at mean. You have 10 51. So you multiply 51 by 10. And then you have 12 52s. So you multiply 52 by 12 and so on until you reach down here where you have 860. Then multiply 60 by 8 to get the total weight. And then you divide that by the total frequency. So you add up all the frequencies. Add up all the frequencies here. At 51, you have 10. At 52, you have 12. At 53, you have 15. At 54, you have 17. So you add up all the frequencies. And so you get a total weight of 8,318 divided by a total frequency of 150. And we get 55.45333, rounded off to 55 kilograms. So we can say that the mean here is 55 kilograms. Next, let's find the median. So we already found mean and mode. Now we are finding median. Well, from the previous part of this question, we had a frequency of 150. We add 1 to that and multiply by 0.5, which will take us to about halfway. So we need to look at the 75, little past the 75th position. So this is our frequency here. Again, this is the cumulative frequency. By the time we reach here, we would have counted 10 of these, just to reference it here. And then by the time we reach here, we would have already counted 22. So from the time we start over here, we're at 23. And we go here to 37 and so on. Now we want to reach 75. So this point here will take us to the 74th position. A little past there will take us to the 75th and so on. So that's the 74th position, will take us to 55. If we count all the 56, we will reach the 99th position. So obviously, our answer will fall here within this 56th position. So our answer for the median, Q2, is 56 kilograms. 56 kilograms. The range, now if that is 50 and this is 51, we are beginning here. Halfway from there will take us to this point. So this is the lower boundary, this is the upper boundary. The range is the difference between the upper boundary and the lower boundary. So we get 10 kilograms. 60.5 minus 50.5, we get 10 kilograms. That's a range. Note we are using boundaries, not limits. So the range is 10 kilograms. Now let's deal with the two quartiles, the first and the third quartile, so we can then get the interquartile range and the semi-interquartile range. So we know that we have a frequency of 150. We add 1 to that, and we multiply by 0.25 to give us Q1, which is somewhere around the 37th position. Now, this one is a little tricky. Why? Because by the time you finish counting all the 53s, you have finished with the 37th position. If you start counting 54, you have moved over into the 38th position. But the thing about it is, we want a position between 37 and 38. So obviously, we will add these two and divide by 2. Because we are not going anywhere near the 54. Somewhere here. So we have just passed the 37. We have not yet reached the 38th position. So we'll find the mean of the two values at those positions, and we get 53.5. So Q1 is 53.5. Let's find Q3. So we take the frequency, add 1, multiply by 0.75, which is 3/4, and we get 113.25. So by the time we reach here, we would have counted 99. That's at that 56. We finished counting all the 56, we reach 99. From the time we begin counting in 57, we would have started 100, but we are not going to 150. We fall short. So it falls here, which is the 57. So we get 57 kilograms. That's Q3. Now, interquartile range, of course, is the difference between Q1 and Q3, which is this green line here. Q1 we said was 53.5. Q3 we said was 57. So the interquartile range would be the difference between Q3 and Q1. It's 57 minus 53.5, and we get 3.5. So that's interquartile range. And finally, the semi-interquartile range is half of the interquartile range, which is 1.75. So now we have those 7 pieces of information extracted from this graph, just from the graph. We can reference this table over here to see if we are on the right track. But for this objective, you are not given this table. You're just given the graph. So this is what we have. Let's go on the online calculator and see how our answer corresponds. I entered the information, 51, frequency 10, and so on, 60, frequency 8. The online calculator spell it out completely here. Each of the numbers as if though they were a column. Online calculator says that the mode is 56, and we got the mode as 56 from our graph. Online calculator says that the mean is 55.45. We rounded that to 55. The median from online calculator says 56. We got 56. The range that online calculator said is 9. We got 10, and we know why that happens. Because the online calculator uses limits rather than boundaries. But CSEC tells us to use boundaries. The first quartile, 53.75. Okay, we got 53.5. Q3, 57 online calculator. We got 57. Keep in mind that the online calculator is more accurate than the information we extracted from the graph. Interquartile range, 3.25. And we got 3.5. That is because of this Q1 that we had different from the online calculator. And the semi-interquartile range, 1.75. And they gave us as 1.6. So very close. And they call semi-interquartile range the quartile deviation. So we did excellently obtaining these results up here from a graph when we compare that with the online calculator. But we still have one more thing to do. Is there any trend or patterns? We look at that graph. Maybe when we look in here, we can see that 71% of these students, they weigh between 53 to 58 kilograms. So most of the students are not too thin nor too fat. Well, maybe we shouldn't say fat. That's not politically correct, but you get the idea. If you find this video useful and interesting, please like and share. That is to say, like and share. You may also consider subscribing to this channel.